Welcome to our deep dive into the fascinating world of neurobiology and mental health, all wrapped up in a lighthearted journey through some complex but intriguing topics. Imagine your body as a bustling city where every molecule has a role, and even tiny pathways can have big impacts on how we think, feel, and stay healthy. Tryptophan. Yes, the amino acid you've probably heard of in your turkey dinner. Tryptophan is a neutral amino acid, meaning it's one of those building blocks our body uses to make proteins. But it's not just about stuffing ourselves at Thanksgiving. Tryptophan is also a superstar in the brain. It can take two main routes, the serotonin pathway and the Kynurenine pathway. The serotonin pathway is like the happiness highway. Tryptophan gets converted into serotonin, the famous neurotransmitter associated with mood, sleep, and even appetite. Serotonin then can be transformed into melatonin, the sleeping hormone, helping us catch Z's at night. On the other hand, the Kynurenine pathway leads to metabolites like kynurenine, quinolinic acid, and kynureninic acid, which play roles in neuroprotection or neurotoxicity. These pathways are part of our body's metabolic pathways, and they're tightly regulated. During infections or inflammation, certain immune responses kick in. For instance, interferon and pro-inflammatory cytokines like tumor necrosis factor can activate the kynurenine pathway, leading to increased production of metabolites like quinolinic acid. Sometimes this can cause neurotoxic effects, contributing to neurological or psychiatric disorders, especially when combined with neuroinflammation and oxidative stress. What triggers these pathways? Well, things like lipopolysaccharide from bacteria, it's a bacterial alarm bell, can stimulate immune cells like macrophages and microglia in the brain. When activated, these cells release cytokines that influence tryptophan metabolism. It's a delicate balancing act, with some metabolites like kynureninic acid acting as neuroprotective agents, and others like quinolinic acid potentially causing exotoxicity, a fancy way of saying brain damage due to overexcited neurons, especially via glutamate, which is our brain's main excitatory neurotransmitter. This brings us to some of the receptors involved. G-protein coupled receptors, nicotinic acetylcholine receptors, and the AR hydrocarbon receptor are all like tiny antennae on cells, sending the environment and triggering responses. For example, the hydrocarbon receptor can bind to some tryptophan metabolites, influencing immune responses and gene expressions. In essence, our body's metabolic pathways involve tryptophan are a complex dance of synthesis and breakdown, influenced by immune signals, microbial activity, and cellular responses. But understanding this web of interactions opens the door to new treatments and therapies, and maybe even ways to cheer up.